Hey, it's Professor Davis here, and we're going to talk about computing combinatorics using the TI graphing calculator. In particular, we're going to talk about computing factorials and computing permutations and computing combinations. So let's get started, and we'll do this by example. First thing we want to do is talk about computing factorials. So let's take a look at this example here. It says signal flags are used by mariners to communicate between two ships, from one ship to the other, or from a ship to the shore. And the order in which the flags are raised determines which message is being sent. Notice here some of them are, I have a pilot on board, I'm carrying dangerous goods, I have an urgent medical situation, that kind of thing. Let's say there are 10 flags that are raised. Now they're all different looking flags, as you can tell by this picture here. They're all different in their configuration. The question is, how many different messages can be made? Well, let's give this a little bit of thought here. In this case, order is important because the way in which you raise the flags gives a different message. And there's no repetition. You don't, like we said, all 10 flags are different. So we're going to use all 10 flags, and the number of possible message given is by, well, think about it here. The first, there's 10 flags, so the first flag can be raised 10 different ways. And then you've used the first one, so there are 9 different ways to raise the second flag, all the way down to the last flag. There's only one way to do the last flag. And so that's 10 factorial. So let's get our calculator out here. Now I have a TI-83. If you have a TI-84, it works exactly the same way. And the key we want to hit here is the math key. It gives a lot of different mathematical operations. And the menu we're looking at here is the probability menu, PRB. So I'll just scroll over to that. And we want the factorial operator, that exclamation sign. That's number 4 there, so I'll just, that's what we're going to use. So let me get out of this. Now let me show you how we compute 10 factorial. We'll type in 10. Go ahead and hit the math key. Go over to the probability menu. Go down and select the exclamation point. And there it is. So it looks like there are 3,628,800 different ways to make these messages. And we do that by computing 10 factorial on our calculator. So the factorial key, that was math, probability, and option 4. Now let's go into our next example here and talk about permutations. We want to use these under 2 conditions. First, order is important. In other words, there's a ranking involved. And then secondly, different from before, secondly, there's no repetition. In other words, we sample without replacement. All right. Now, I guess the difference between this and factorials is, with permutations, you may not, sample. You may not use everything in the sample for your selection. So let's go ahead and take a look at this example here. The 2012 Belmont Stakes had 11 horses in it, and a trifecta is a type of bet in which the bettor must predict which horses will finish first, second, and third in exact order. I guess that's called win, place, and show in horse racing. How many different ways could a trifecta bet be placed on the 2012 Belmont Stakes? So think of what we have here. We have a sample size, so to speak, of n, which is 12. Excuse me, it's 11, isn't it? 11 horses were entered. And we want to select 3, the top 3. First, second, third, win, place, and show. Again, there's no repetition here, and order is important. So the number of possible ways is given by the permutation, 11, select 3. So let's see how we do this in our calculator. Now you could, by the way, I just wrote it in factorial notation. You can use the factorial operator and do it by the factorial definition of permutation, but the permutation operator is built into the calculator. So let me show you how to do that. The tricky thing here is to remember to put in the n part, which in this case is 11. Put that in first. All right. We want to do it just like we see it here. So we'll hit the math key now, go over to the probability menu, and now notice here, if you look at option 2, it says NPR, all right, for permutation. I'll go ahead and hit enter. And then the number of items we want to select out of the 11 is 3. So we'll go ahead and hit enter there. And we get 990. So it looks like there are 990 possible trifecta bets that can be made in that 2012 Belmont Stakes. Alright, so there's Factorials, Permutations, and now Combinations. Let's take a look at that. Now, in the difference between combinations and permutations is order's not important with a combination. Alright, or there's no ranking involved. We can pick them in any order. But there is no repetition. In other words, we sample without replacement. So let's take a look at this now. How about this? In the Ohio Lottery's classic lotto game, 6 numbers are drawn from a single bin of 49 numbers. You've probably seen it before, and you see the balls here with the numbers on them. And how about this? Order is not important in which they're drawn. How many different classic lotto outcomes are possible? Alright, so let's think about the scenario here for the classic lotto. In this case, order is not important, and there's no repetition. The order in which the numbers are picked doesn't matter, and there's no repetition. In other words, there's only one bin where these balls come from. So the number of possible outcomes is given by the combination 49 choose 6. There are 49 balls in the bin, and 6 are pulled out. So let's go ahead and compute this now. Same sort of operation as we did with the permutation. Put in 49. Go ahead and hit the math key. Go over to the probability menu, and now notice here in option 3 is the combination. And then we'll go ahead and hit enter there. Put in 6. Ooh, so what do we got there? 13,983,816. So that's how many possible outcomes there are to the classic lottery game. Now let's just go ahead and verify our answer, by the way, here. So I looked up the website here for the Ohio Classic Lotto, and here are the rules. It says we select 6 out of 49 numbers, and notice here, if you look at the odds and payouts to win the jackpot, well, take a look at that number. That number is exactly what we computed when we did the combination of 49 choose 6. That's the odds of winning the jackpot, 1 in that number. So you can see the power of combinations here, and a lot of these lottery games are certainly built around combinatorics, and that was the purpose of this screencast.